Okay, this will be a fun problem. This is Parallel Forces Part 4. And we have a person lying on a table. And there are two forces on the ends and the head and the feet supporting it, 623.1 newtons up and 456 newtons up. And the weight of the table is 294.3, so we've put that right there in the center. And what we want to do is we want to figure out where is the center of gravity of this person. This person is not, people are not uniform. Their center of gravity generally are not right in their middle. And clearly you can see that this one is not. The center of gravity of this person, the weight of this person, must be above his waist. We can tell that right away because the top part of this body is heavier than the bottom part of the body. So the center of gravity must be somewhere above his waist. And we want to figure out how far basically from the feet, because I want to know what is the percentage from the feet, what is the percentage of his height from the feet that the center of gravity is located. So if we start here with our basic things, we have ups and downs. We always remember we make a chart of these ups and downs. And for ups, we have 623.1, and we have a 456. And downs, we have a 294.3. And so that means we need some more down. And so if we add these two up here, and then subtract our 294.3, we'll see that that'll leave us with 784.8. So we need 784.8 down, which basically means that is the weight of this person. That is the weight of the person in newtons. But that's not what we're trying to figure out. We're trying to figure out where should I put that weight vector. Clearly it's going to be down because it's the weight, but where do I stick it on here? Where should it go? So what we want to do is we want to do torques now, and we're going to use our feet here as our reference point, and we're going to do clockwise and we're going to do counterclockwise torques. So if this is my reference point, that means any forces going up are going to go around this way, clockwise, and any down forces are going to go around this way, counterclockwise. So let's look at our clockwise torques. I only have two up arrows, but this one's working right on our frame of reference, so we don't have to worry about it. But here I have 623.1 times how far across are we? Well, I never gave you any measurements for this board. So we're just going to make up some for this board. We'll just say it's 1 unit long. Maybe it's a meter or whatever, but we're going to say 1 board length. So I'm going to take 1 times 623.1, and that's going to be a clockwise torque. So I'm going to have 623.1 as a clockwise torque. And then for counterclockwise, I'm going to have this force, 294.3 times how far out is that? Well, if the whole thing is 1, then that's going to be 0.5. So we're going to take it times half. And then I also know that I have another counterclockwise torque. It happens to be the weight of this body, which is 784.8. But I don't know where it is. I don't know how far out the weight, the center of gravity is for this object, so I know where I put this weight. So I'm going to put in there X. And so this is how I'm going to figure out how far from the feet the center of gravity is, because all I have to do is set this right here equal to this plus 784.8x. And so I can do an equation there. I can do 623.1 should equal 294.3 times 0.5 plus 784.8 x. And so I could take this and subtract it from this and divide by 784.8, and I can do, it's just basic algebra, and I can figure out that my x equals 0.61. So remember, I was trying to actually figure out what percentage of the way from the feet is the center of gravity of this body. And so if I set the bar, the table, to be 1, 0.61 is going to be 61%. So the center of gravity is 61% of the way, of the height, from the feet. 50%, of course, would be right in the middle. So this center of gravity is clearly above this person's waist. So one of the part 2 questions of this is this a man or a woman? And so that's kind of, people think, well, that's kind of a weird question. But really, as general, and it's somewhat stereotypical, but it's, I'd say probably about 90% true. The center of gravity in males is always higher than it is in females. So the center of gravity for males is usually above their waist. They usually have broader shoulders and their upper torso. We're going to draw the shape of a male. We're going to draw more like this with upper body strength. For females, we're going to draw them more like this. We have usually larger hips than males do, and so the center of gravity gets skewed downwards for females and upwards for males. And there's a lot of different tricks and things we can do that we can do in the class of demonstrations that generally females can do and males can't, because their center of gravity is so much closer to the ground than what they can do. So one of the things we can do is you can take have a wall and get a chair, put a chair here kind of next to the wall, and have either a male or a female stand out here and bend over and put their head on the wall, and then reach down and grab onto the chair on both sides of the chair, lift the chair up off the ground, and then try to stand back up. And generally, and usually what you do is you kind of, to know where you're supposed to stand, you kind of take 2 of your feet length away from the wall, and that's where you stand. And if you lift the chair up off the ground and then try to stand up, most of the times the guy will not be able to stand up. A lot of the times the girl can, because if you need to be balanced, you need your center of gravity directly over your pivot point, which in this case is your feet. So in the female, the center of gravity is lower, so it might be somewhere down here, and it's actually over the feet, and therefore you can still stand up even though you have all this weight out in front. But for the male, the center of gravity is usually up higher above your waist, and therefore it's too far outside of your feet, and you just keep bashing your head into the wall the entire time. So it doesn't always work that way, but generally, as a rule, guys cannot stand up, and the girls can if you're doing this demonstration. So that's just a matter of center of gravity being generally lower in women than it is in males. So hopefully that makes a little sense, and it's physics applied.